Well, hi everyone. Thanks for your time watching this video. And thanks to Dave Sands for inviting me in again. I've done this the last several years for this class, and I've really enjoyed getting to know Dave better and getting to be friends with him. And I've really enjoyed getting to meet students. I won't, of course, get to meet you in person this year. I'm hoping that we can answer some questions virtually. You can certainly email me questions, and you can certainly email me follow-up questions in the weeks ahead if you have them and want to correspond. I'll be glad to do that with you. I'm a population ecologist in the ecology department here in Bozeman at Montana State University, and I've had that job since 1992, and I've been involved with the project here in Antarctica that I'm going to talk about today for the last 19 years. So I get to work on teams of researchers on quite a variety of species. Currently, I'm involved with studies on elk, bighorn sheep, mountain goats, a couple of interesting species of fish, such as our endangered pallid sturgeon in our more eastern Montana rivers. And I'm also involved with some bird studies, such as a study on trumpeter swans in Yellowstone National Park and greater sage grouse here in Montana in a nearby area just outside the park. So I feel very fortunate to have the job I do and to get to live in Bozeman and experience so much time outdoors in Montana. I love wild animals and I love wild places, and so I've kind of fallen into a dream job, and I hope you all are able to find yours. And courses like this open your eyes, I hope, and get you exposed to a whole lot of options that are out there. And so I want to get right into it and give you an overview, just a brief overview. This project's been going on since the 1960s, and so there's a lot of different things we could talk about, but I'm just going to give you an overview and a little taste of some of the very low-tech things we do and some of the higher-tech things we do, and introduce you to a pretty neat species in a pretty neat place that I love being and I love talking about. So I'll turn my camera off and get you over to the slides here. So Weddell seals are the topic of the day. They live in Antarctica, and the project I'm going to talk about is conducted by myself, Jay Rotella, and then my co-investigators, Bob Garrett, who's a professor here at MSU, and Don Siniff, who's now a retired professor at the University of Minnesota, but ran this project for decades and continues to be involved with us. And we're very fortunate that he's doing that because he has a very long view and trained an awful lot of great students on marine mammals and wild horses and a variety of things. So he has a lot of knowledge, and we're very pleased that he has stayed involved with us. So this project is funded by the National Science Foundation through the United States Antarctic Program, and the grant comes to Montana State University, and Bob and I are the professors here that run it. So this is a picture of a Weddell seal and mother and her pup. It's a pretty new pup on the ice, and we'll talk through a little bit about these animals and where they live and a few of the things we've learned here in the next half hour or so. So we fly to Antarctica but using commercial airplanes to get us down to New Zealand, and then we get to Christchurch, where we have a joint facilities with the New Zealand government, and we get to Christchurch and we get our gear and our clothing anyways, and a little bit of training, and then we get on a U.S. Air Force cargo plane and fly about 5 hours to 8 hours, depending on which type of aircraft carrier we're on. And you fly to the bottom of the Pacific Ocean below New Zealand. And as you fly down and get closer to the continent, you start to get these absolutely remarkable views. The scale of the place is massive. These glaciers you're looking down at are probably about 5 miles across. Here they're dumping out onto the ocean, so the left-hand tips of those glaciers, those feathery-like features you see in the sea ice, those are glaciers flowing down out of the Antarctic mountains, and some of those are running massive distances. up into the continent and coming down and floating in the ocean. And then, of course, tips of those break off and form the big, fantastic icebergs. This is from about 30,000 feet, so you have to think about just how big those features are below you. These mountains are a bit bigger than the ones we have, our biggest peaks here at home in Montana. So it's a spectacular place, and it is protected through international treaties. The land and then the coastline is protected. The oceans vary in terms of protection status, but really a big, remarkable wilderness. The Weddell seal, which is the star of the show for this talk, is a truly Antarctic species. It is the southernmost mammal on the planet, and they are found around the Antarctic coastline in various embayments that have frozen ocean over them. This animal is what we call pagophilic, P-A-G-O-P-H-I-L-I-C, pagophilic. It means it loves ice. So the animal truly is an ice-loving species, as you'll see. So the oldest animal we've ever recorded was a 31-year-old female, and we've had some males live into their 20s. The world's population is somewhere in the hundreds of thousands. It's certainly below 1 million. We'll talk at the very end about some recent satellite-based work that maybe suggests the numbers are a little bit lower than 800,000, but the animal is not thought to be endangered. It's at least in the hundreds of thousands. It's about the size of a horse and can weigh 1,000 to 1,400 pounds, so in that ballpark, and very, very charismatic in my opinion, because their mouths have this little smiley appearance, and that has to do with the way the jaws open for chewing cracks to make openings to haul out of the water and up onto the ice. So they have these very wide opening jaws, as you'll see in a little bit. So the animal is remarkable. It is the second best diving mammal in the world, second only to southern elephant seals in terms of diving abilities. It can hold its breath for over an hour and dive many, many hundreds of feet and exploit fish at very, very deep depths, like around 1,000 feet of depth. So really remarkable. And so here you can see light shining through a crack in the ice, and the seal has sunshine sort of glinting onto its back through a hole in the ice. And you can see it back in the corner there, and you can also see some of the sea life. It's quite a lively place underneath the ice. It looks kind of stark and bleak on top, but it's quite lively. So the Weddell seals haul out at this time of year along the Antarctic coastline, and what happens is the ocean freezes and the tides still go up and down, and so you get a crack along the coastline because the ice sheets are moving in the wind and currents are moving underneath these ice sheets, and then the tide is going up and down, and the ice is attached to the shoreline and can't really move, but then out 10, 15 yards away from the land, the tide is going up and down, and of course the ice cracks, and you can kind of make that out. Right here you can see a tide crack that's formed, and the animals are hauled out along it, and it forms all along here. So these animals haul out, and then they will give birth this time of year. In fact, they just started giving birth in the last 10 days or so for this season, and the peak of pupping will be right around Halloween every year. Of course, it's spring down there right now, and so the days are getting extremely long, and about now the sun will be up 24 hours a day. Here in this picture you can see this is the ice that's attached to an island in this case, and here the tide is low tide, so the ice out over the ocean is down about 1 meter, and so we get this little bit of freeboard, and it cracks because the island is like right at the edge of this photo. So mom and pup, there's probably a mom right here and a pup, and then a mom and a pup, and a mom and a pup, and so on. So these are colonial animals that haul out in places that are quite remarkable in a few features. One of the features is they're safe from predators. They're back in under these ice sheets. They use their diving ability to get back in under the ice and away from their main predators, which happen to be killer whales and leopard seals. The other wonderful thing about them is they happen to build big colonies of animals out on this frozen sea ice where we can build a camp. Here's our field camp, and conveniently there are a number of colonies near McMurdo Station, which is back kind of where that tip of that island in the middle right of the photograph is, about 20 miles away, 16 miles away, depending on the route, to a pretty big field station that the United States government runs. The McMurdo Station is our biggest base in Antarctica. So we have cargo planes can come land on that sea ice up there. They maintain ice runways, and we have supplies, and we have science labs and areas where we can go get food from a warehouse and go get snowmobiles repaired and so on. So we have some remarkable facilities. The animal also has some remarkable abilities, and that its breath holding and diving ability let it exploit these ice sheets and be away from predators. And that, we believe, causes the animals to be quite tolerant of us approaching them. So these animals use these same sites year after year throughout their lives. So if we tag this pup at birth and record its numbers, we'll know who it is for the rest of its life. And we'll know who its mother is by tagging her, or because she was tagged earlier in her life. And because they're so faithful to the site and so tolerant of us and just lay on the ice for weeks at a time right after birth while they nurse and get big, we can really study massive numbers of this 1,000-pound carnivore. Trying to do the same kind of thing here with 1,000-pound carnivores that live around Montana is a lot more difficult, as you can imagine. Grizzly bears are a little trickier to study. So we are at the bottom of the Pacific in the Ross Sea is the bottom of the Pacific, and we're in an embayment called Erebus Bay. The island here is Ross Island, and this is where Scott and Shackleton and Amundsen all went to this area because it's as far south as you can get by boat. Shackleton and Scott, the British explorers that were trying to be the first to get to the South Pole, they have huts that still are standing in our study area from when they were doing their work in the early 1900s. And so it's really a remarkable place. On the top of Ross Island is Mount Erebus, the world's most active volcano, or one of the world's most active volcanoes. And over on the right-hand side, we have a little zoomed-in view of the island. And so north is up on this image. And what we get is colonies everywhere. There's a little island breaking up out of the sea ice, or this floating glacier tongue coming out and floating on the sea ice. And then these coastal areas where glaciers come down and disrupt the sea ice. All those places that get good cracks, we get seal colonies. And the low-tech part of our work is tagging all the individuals that are in the population. So every year we string thousands of tags and that are uniquely numbered and colored. And then crews of students and recent graduates are hired through Montana State University, and they go down and live in our field camp for 2.5 months and tag every seal pup that's born, tag any untagged mom, which is, so we do get some immigrant mothers that come in from outside, and so we tag those as well. Everything goes in notebooks, everything goes in field computers, and we just spend a lot of time outdoors walking through colonies of seals, which is absolutely fantastic. People like to know sometimes about the weather. It is a windy place, and it is winter. This is the beginning of our field season. Our crew this year arrived in Antarctica about 10, 12 days ago and began tagging seals this week. And the peak of pupping will be right around Halloween every year in the austral spring. So it is now getting to be about 24 hours of daylight, and will be for the duration of the field season, which ends in just before Christmas. So the seals swim back in under these ice sheets, haul out through the cracks, give birth about now over the next 10, 15 days. nurse their pups heavily for the next month up until about Christmas, and then abandon the pups and go try to get big to do it all again the next year. So our job is to walk around the colonies and tag the animals, survey the animals, and learn what we can. So it's a pretty spectacular place, but I mentioned the weather. It is a windy place, and even though it's austral spring, I think the temperature down there the other day was about 20 below. 10 below to 10 above is very common this time of year, and it is windy. We commonly are working at 5 degrees and 40-mile-an-hour winds, and we pay close attention to the wind and the weather because it can turn into a whiteout in a hurry in a big and white environment like this. So you'll see flagging, these bamboo poles with flags on the top. Those are really helpful for getting around, and we have these routes flagged over there. We probably flag about 30, 40 miles of routes each year and then take all that down at the end of our season. But those really let you navigate safely and get back to camp in safety when the wind starts blowing a little bit of snow that there is down there. This is really a desert environment. It doesn't snow that much, but the snow we get blows and moves around a lot. And it can be a blue sky above, but a very blizzardy condition down on the ground. So we spent a lot of time applying tags and recording the identities of tagged animals that we're seeing. These are animals that we've seen and tagged in previous years. And these tags are extremely low-tech way of keeping track of these animals over many, many years. And if we see tagged animals whose tags are getting worn or beaten up or broken, then we replace those. And so this is straight out of the livestock industry, right? So cows and sheep, they put the ear tags in the ears, we put them in the flippers, but you can keep track of your individuals this way. So very simple. So since 1973, the project has tagged over 26,000 individual seals. Each seal has its own unique combination of color and number. We sometimes get asked if we have tried other technologies that are a little more sophisticated, and people have tried some computer chips in tags. We'll probably try that again here soon, the RFID, the radio frequency tag. Technology's improved dramatically. We've stayed with the tried and true, simple and cheap method. We use fancy analyses, but we use pretty simple field methods. It is easy to break equipment down there. Amazing how many things break when it gets that cold, and these animals are swimming in the Antarctic Ocean and crawling across the sea ice. I mentioned the animals are very faithful to the site, so these animals, if they're alive, tend to be using the study area. So we have close to 300,000 resightings of animals that have been tagged, and because we tag so many pups at birth, we know the ages of most of the animals and have most everyone marked. So if we tag you as a pup, we know the year you were born, and then every year after that we know how old you are. That's really valuable in a wild animal because things change in wild animals as they age. Their propensity or tendency to give birth, the probability that they'll stay alive to be again in the population next year. All those things change from the time an animal is born until the time it gets to be up to about 30 years old and is no longer with us. So we use these tags to try to understand things. And so at the beginning of the year, we're going out and walking through, this is a glaciated area, we're walking through an area like this and tagging any untagged animal, any newborn pup, and recording the numbers of animals and the identities of all the animals so we can keep track. One of the simplest things we do then at the end of the year is tally up how many pups were born, and because they're laying on this white ice and we can get in a helicopter and look around from the air, we do a good job of tagging nearly everyone and can get a pretty total census on these animals. So going back to 1980 here, the number of pups, the production was very steady up through most of the 90s. Then in the late 90s, we had an uptick in the blue horizontal or vertical bar, excuse me, the blue vertical bar here. Just around 2004, we had a plunge in the number of pups. That's when we had a massive iceberg break off the coastline and block the bay for a few years. So we got to see what a big disturbance like that did, a natural disturbance. And then we got to see the population recover from that. And since then, it's been producing more than average pups in recent years. So that's been interesting. Those are the kinds of things we're quite interested in. Why did the decline occur? Why did the increase occur? And so on. We also study the arc of life of these animals. And so by that, I mean, as you go from birth to old age, what happens to your probability of surviving from one year to the next. So a very young animal typically has fairly modest survival rates. About 50% of our newborn pups will survive to be yearlings. About 50 to 60% of one-year-old animals will survive to be two-year-olds. And about the time they get to be 3 years old, they get to be pretty big. They've figured out how to stay alive down there. And then the survival rates for these big animals that are fairly high in the food chain and that live in a predator-free environment at least parts of the year, their survival rates jump to about 90% for a good bit of the middle part of their life when they're in their teens. They delay when they start to reproduce. They don't start to give birth to pups until they're about 7 or 8 years old. It takes them a while to get good at finding food, and let alone for themselves, but also to take care of a pup. And they peak in their teens, and then they start to break down, and most animals are gone by the time they're into their 20s. So there's very much an arc of life where they peak in their performance of survival and producing offspring when they're in their teens. So it's good to be in your teens if you're a Weddell seal. This is a very healthy mom and a very healthy looking pup. I want to talk just briefly a little bit about the details that we get into. So as I said, we use the tags to keep track of how long each animal lives. Is an animal giving birth this year? At least the females who tend the young alone, we can tell when they've had young. And the mothers do a tremendous amount. And I mentioned that they don't start producing young till they're 7 or 8. And so I want to talk a little bit about how they care for the young, and that'll give you a sense of why they might delay a little bit in terms of when they start. So a newborn pup, pictured in this upper left picture, is born at about 70 pounds, so about the size of a Labrador Retriever, or about the size of a second grader human. And the mom might be 1,000 pounds, might be as big as 1,400 pounds if she's really big and really a particularly large adult female. And so huge weight differential, and the mother is just absolutely fat. Okay, so seals have a layer of blubber. They also have, or they can have, fat throughout their body, organ fat and so on, much like we do. But they also have this outer layer of blubber that helps insulate them from the cold, helps them float, helps keep them warm, and parts of it at least can be an energy source. The mothers then nurse their pups for about 6 weeks, 4 to 6 weeks, depending on the mom, and they'll lose a third to a half of their weight during that time, and they don't feed hardly at all. They go in the water with their pups, as we'll see in a moment, to perhaps teach them to swim, but they don't tend to catch much food during that time. And so the mothers are living off stored body reserves, a strategy of breeding called capital breeding, where they're living off of stored capital or stored body reserves. And during that time, the pup will gain about 150 pounds, and the mother will lose perhaps 300 to 500 pounds. And the pup gets to be this big, blobby looking thing, and the mom looks like this skinny thing. And so there's this huge transfer of energy. So we have observed that some mothers look a lot bigger than others. Some pups look a lot bigger than others after they've nursed for a while. And so we've spent a lot of time doing some slightly higher tech things, trying to learn about the masses of mothers and how much energy different individuals are transferring over to their babies. So the simple thing, when a mom gives birth, a couple days after birth, you can take the seal pup and put it near a weighing scale opposite the end the mother's at, and the mother will try to get close to her pup, and she'll crawl through the scale. And this is a cattle livestock platform, and she crawls through, and on her way through, you get her to stop by putting your hand in front of her face, and you get a digital readout, and that's what the person on the right side of the little sled is doing. So you crank the skis down, and the sled lifts up, hook it to a snowmobile, drive it to the next mom, and you can do this. But it's really tedious. But later, they're not going to go through there, and as their pups get older, they are a little less inclined to want to be right next to them all the time. And they'd rather call to the pup and get the pup to come to them. So later on, we actually use a technique called photogrammetry. And there we're putting these scale bars around the animal and take pictures from lots of angles. And then we use some 3D software back in the lab to estimate the volume. And because we've weighed a bunch of seals on the platform, we can then correlate the volume to the amount of mass. And then we can just now, we don't have to put anybody on the scale, and we can just use photogrammetry for everything. The higher tech version of this that's coming is people are now using drones to do photogrammetry of hundreds and hundreds of animals. We haven't quite done that ourselves yet, but some of our colleagues are, and we're hoping to move to that soon. So we get a little higher tech on this part as we try to learn about this, because picking a 1,000-pound animal up out on the sea ice is not trivial. A couple of graphs real briefly. What we've learned is we've got maternal age across the horizontal axis, the x-axis, and then the mass of a mother, what she's predicted to weigh as she goes through age. So here's these brand new young moms at 7 or 8 when they first start, and then their weight climbs to when they're in the late teens, and then they start to weigh less. Physiologists that study the seals have also shown that their muscles are senescing, they get more connective tissue, and are less reactive, perhaps some senescence or sort of breakdown, physiological breakdown as they get older. We also weigh pups. They're a little easier. We can put them in a little handling bag, looks like a bit like a duffel bag, but very reinforced, and a breathing hole in the end for their nose to come out. And we see that pups born to various mothers, here's the age of the mother. So the teens, as I mentioned, is when the mothers peak their weight. And pups are born to teenage mothers tend to weigh more than pups born to particularly young or old mothers. So we've been doing this work, and now we're interested in seeing if pups that weigh more tend to survive better. You might think they would because they're living in the Antarctic, and starving to death is a fairly real threat in a place like that in the cold. The other thing seals have to do is not just get big and develop body fat, they also have to learn to be seals, which means you have to learn to dive and catch fish and evade predators when the ice breaks up. So here's a mom and a pup swimming together. Moms very actively call to their pups. This mom wants her pup to come in for a swim, it appears, and the pup would like the mom to come out and give it milk, but the mom just stays in the hole and calls to the pup, and the pup investigates it. That water is about 28 degrees Fahrenheit. It's got salt in it, so it doesn't freeze until it's a little below 28 degrees typically, and it's cold. Well, you put your arm in there, which I've certainly done, to check it out. It is pretty numbing experience. So I'm sure for this pup to put its nose in there is quite remarkable at first, but they do go in, and it takes them a little while. They're pretty uncoordinated at swimming at first, early in life, and then over the course, there he goes, over the course of a few weeks, they certainly learn to swim, and they swim quite closely with their mothers, it appears. The getting out is not trivial. And so mothers chew the holes, they enlarge these holes, and try to make a nice smooth ramp for the use. They've got these very forward-facing teeth that make your head smile. So you get get the idea there. The mothers will chew a ramp, and if the pups struggle to get out when they're really young, the mothers will actually push them out. They'll get underneath them and sort of push them out on top of their head or their shoulders. So they're very attentive mothers. And one of the other little things we do, sort of a mid-tech, is we attach little temperature loggers onto the flippers of pups, and we keep track of how much time pups swim in the water. We just had a grad student here at MSU, Shane Petch, complete his graduate work on the swimming times. And he found that some pups hardly ever go in the water. We call them couch potatoes or sea ice potatoes. And we think they probably gain more weight because they don't have to burn calories going in the cold water. But we're very interested to see if the ones that swim more become better athletes perhaps and go on to survive better. We can use those tags to see who's surviving, and so we're going to relate the amount of time pups spend in the water to their survival here in the next couple of years. So I've told you a little bit about our seal work. We also get involved in some high-tech work, and we'll wrap this up here. We have worked with some teams that are doing counts of seals from space, a citizen science project that just wrapped up recently. Tom Nod campaign looks for lost airplanes, hurricanes that might be forming, and so on. One of the projects they've done was with some researchers that we've collaborated with to count Weddell seals. And so we gave the researchers, Michelle LaRue is one of the really talented people that's running that. She's a professor from the United States that's working in New Zealand right now. And they got volunteers all over the world to count the number of seals they saw on satellite images. And here's one of the images that has seals in it, and counted them up. And so they're trying to use more interesting technologies of the internet and satellite images to keep track of the continental or the global population of Weddells. And so here you see the seals surrounded. And we also are involved with people from Goddard Space Center and NASA who keep track of sea ice in the Antarctic and the Arctic. And certainly with interests and concerns over climate change, there's plenty of work going on through these kinds of efforts. And as you know, there's interest in what's happening with the ice sheets in these two polar regions. And up until recently, we had ice levels in the area of Antarctica where we work, which were actually increasing. And so we had more extensive ice sheets in recent decades than had been recorded maybe 40 years ago. So that changed in the last couple of years, at least in the short term. We don't know what the long-term pattern is yet. But this paper just came out, and if you're interested in polar sea ice, Claire Parkinson, this is the woman at Goddard Space Center who is one of the head people on this. She's an absolutely fantastic scientist. And she's been a great collaborator. So we work with her on the sea ice data. And so you can read about Claire here. This is the Proceedings in National Academy of Sciences article that Claire published last year. And I just want to mention this one item here, that what she has found, that slide animation didn't quite work the way I expected, but what she found in the paper that came out last year was the last 5 years have shown decreases in Antarctic sea ice that are more rapid than anything that's been seen in the Arctic. And whether or not that is a long-term trend or just an anomaly is not yet known. So we are working with them because we're interested in what's going to happen to a seal that is an ice lover and depends on these ice sheets to protect them from predators and give them a safe place to raise their pups. So that's kind of things we're working on. We were able to field a team this year. They are there. This is the most recent satellite image we have of our study area. And what's notable is this is a place that we normally drive. And this is where we normally have our camp. This is McMurdo here. And we drive up here, and this is open water. So we're not driving there this year. So some of the study area we're only accessing by helicopter and then snowmobiles that were staged in this area up in here. So we staged helicopters. I didn't do it. Our team did it, and some helicopter pilots did it, and they staged a camp right here. They fly from McMurdo up to there, and then they can drive around here and not get too close to this ice edge. Seals normally would have been here, but they're obviously not. Gonna put perhaps seals that breed here at some risk because orcas may have more access to the pups early in life. So it's very interesting as a scientist to see what will happen with these sea ice trends and what that will do to the animals. So with that, I'll thank you for your attention. There's a lot more I could tell you. I'm sure you've gotten some sense of what we do here at least. If you're interested in learning more, our project has a website, weddellsealscience.com, and we also have an Instagram page with little snippets. Weddell Seal Science is also the name for the Instagram, so feel free to check those out if you're interested. And thanks very much for your attention.